R tutorial number 4, Basic Commands in R. This tutorial covers several topics, including starting your first R session, doing simple math in R, using mathematical functions in R, creating vectors and assigning values, storing vectors and calculating values, and finally how to use the help function in R to get the help that you need. This tutorial is also accompanied by an R code file. The file contains all of the commands that we will go through in this tutorial. Please see R tutorial 4 code.r for this file. So let's get started with starting your first R session. And as we've gone through before, you are going to begin by setting the working directory. You can set the working directory using the command setwd or by going to the toolbar, clicking Session, Set Working Directory, and as you remember, we can either choose a directory or set the working directory to our source file location, which will set it as our same directory where we have our source file, in this case R tutorial 4 code.r set up in. So with that, let's start by saying hello to the world using our first function in R. And this function is going to be the print function, which will tell R to print whatever command that you give it. So if you remember, we can run commands using our source file by highlighting them and either doing Command Enter on a Mac or Control R on a PC. So if we do that, we see that down here in the console, we told it to print hello world, and R printed hello world for us. We can do that with any type of text in R. We can print what's up world. We can also print how you doing. But we have to remember that we're going to use the double quotation marks when we're printing something. So for example, if we were to print hey without quotation marks, can highlight it, and R is going to tell us that we have an error. There's an unexpected exclamation point in print hey. However, if we add in those quotation marks, we will see that R again prints hey in this case. Let's move on to our second topic of today's tutorial, doing simple math in R. So R is great for doing super math because R is a giant calculator in many ways, and you can use it for all types of math problems. So for example, here in this text in this R source file, we can add up 1 plus 2 plus 3 plus 4 plus 5, and we'll see that R is going to give us the sum, which is 15 in this case. We can also multiply 5 times 7, which will give us 35. We can also divide 10 by 2, which is going to give us 5. We can also do 7 minus 2 plus 5, which is going to give us 10 in this case. And in addition to basic math commands, we can also raise numbers to different powers. So this case would give us 4 to the second, or 4 squared, which is 16. We can also do 10 raised to the third power, which is going to give us 1,000 in this case. And R also knows how to control for the order of operations. And it follows the please excuse my dear Aunt Sally rules. So it's going to calculate parentheses, exponents, then multiplication and division, and finally addition and subtraction. So for example, we would get very different results if we did 4 plus 2 times 3, which is going to give us a result of 10, versus 4 plus 2 in parentheses times 3, which is going to give us a result of 18. So R understands these parentheses in the order of operations. So you can do even longer types of operations in R. So 12 plus 4 times 7 plus 8 minus 6 in parentheses divided by 2. And that'll give us 41 in this case. So we see that R is able to do basic mathematical addition, subtraction, multiplication, raising things to the powers, and following the order of operations as well. In addition to working like a calculator, R can also calculate mathematical functions, our third topic for this tutorial. So in using mathematical functions, let's start with logarithms. For example, we can say log with 5 in parentheses, and that's going to give us the natural log of 5 in this case. We can do log 1 colon 3, which is actually going to give us the natural log of 1, 2, and 3 for this example. And finally, we can use other bases as well. So in this case, we want the log of 1, 2, and 3 for the base 6. Click on that, and that'll give us those values down here. So we can use the log function in R. And in addition, we can also calculate exponentials in R. So if we want that for 5, we type exp with 5 in parentheses, and that will give us 5 exponentiated, which in this case is 148. If we want to do that for 0.2, we do the same thing as well here. In addition to calculating exponentials, we can also use R to add a series of numbers using the function sum, S-U-M. So instead of saying 1 plus 2 plus 3 plus 4 plus 5, we can simply say sum 1, 2, 3, 4, 5, dividing those up with commas. And if we run that, we get 15, which was our answer from before. And we can also do sum 1 colon 5, which will sum everything from 1 up to 5. And in this case, give us the same answer of 15. We can also use R to find the square root of things using the function square root, SQRT, and putting what we want the square root of in parentheses. So if we want the square root of 144, we can type that in and see we get 12. In addition to finding the square root that way, we can also find the square root by raising something to the 1/2 power. So 144 raised to the 1/2 is also going to give us 12 in this situation. R can also put things in science and scientific notation for us. So 1.33 E4 is actually going to give us 13,300, or 4.12 E negative 2 is actually going to give us 0.0412. We can also even use various mathematical operators when we're in scientific notation. So we can divide these values and see what we get, which in this case is 600. R is also helpful for rounding if we're interested in doing that. So the function round is going to help us in this situation. So say we have a number of 123.456. and we want to round it to a specified number of digits after the decimal. We can put that in here as our first entry into this function, divide that with a comma, and say we want it to round to 2 digits. And what we see here is that it's rounded to 2 digits past the decimal, and we get 123.46. We can also round to a specified number of digits before the decimal by changing our entry into digits from a positive number into a negative number. So if we try that again here, we would get, in this case, negative 100 because we were using negative 123.456, and it rounded to 2 digits before the decimal. And finally, we can also round to this total specified number of significant digits by using this SIGNIF function, where here we're saying digits 4, and that's going to give us a total of 4 significant digits overall. In addition to rounding numbers, we can use trigonometric functions in R. So for example, if we want the cosine of 120, simply type cos 120, or we could do the cosine of 120 times pi divided by 180. That'll give us a value of negative 1/2. We can do sine. We can also do tangent as well. So these are additional functions that we can use in R. And finally, we can also use infinity. So for example, if we were to divide 2 by 0, that's going to give us infinity here because it's an undefined function. We can also use capital I and F as to signify infinity. So 4 minus infinity is going to give us negative infinity. And finally, we can ask if things are finite or infinite as well. So is dot finite? We can type that in. We want to look at 10 raised to some very high numbers. And it'll tell us that, well, for the first 4 of those numbers, that is a finite number, but for the last 2 of them, it is not. So here you would look for trues and falses if we're asking it, is something a finite number? So these are just a few of the mathematical functions that you can use in R. Now I want to shift things a little bit and talk about how to use vectors and assign values in R. In R, and in most statistical programs, a vector is a string of numbers or values. And oftentimes in statistics, the vectors that we work with are variables in our analyses. So let's look at some commands to create vectors. In this case, both commands that you see here can be used to create vectors from 1 to 5. So in this first example, we can use C, which stands for concatenate, and then put our numbers in parentheses in front of it, divided by commas. So here we say concatenate 1, 2, 3, 4, and 5. We tell R to do that, and we get a vector of 1, 2, 3, 4, and 5. We can also use 1:5 to say we want to create a vector from 1 up to 5, and that's going to give us the same result here. In many cases, we also want to assign values to vectors. And the arrow sign here can be used to name things and assign values in R. And it's often convenient to name a value so that we can use it later, so we can bring it back and do additional functions with it. Overall, assignment is pretty straightforward. We put a name on the left-hand side of the arrow sign and a value on the right. Assignment, however, does not produce any printed output. You're going to need to enter the new name to see what was assigned to it. So for example, let's assign the value 4 to the letter A, and let's also assign the value 6 to the letter B. We do that. We notice that we don't have any printed output. However, our new values appear up here in our workspace. And if we also type in A and B, we will then get our printed output, and we'll be able to see what we've assigned to these vectors. So here, if you look over here, you see that A is 4 and B is 6. And now that we've assigned things to A and B, we can use them in a whole variety of computations. Addition, subtraction, division, and multiplication, just to name a few. So if we run these all at once, we can see that for A plus B, we get an answer of 10. For A minus B, we get an answer of -2. For A divided by B, we get 0.6 repeating. And for A times B, we get 24. So in this case, it's doing all those operations using 4 and 6, which is what we've assigned to A and B. Overall, we are free to make variable names out of letters, numbers, and the dot or underline characters. A name generally starts with a letter or a dot, however, a leading dot may not be followed by a number. We also cannot use mathematical operators such as plus, minus, or the multiplication sign when we are creating names. So some examples of different names that we can create are, for example, maybe we want to assign 1 to M, but we also want to assign M to P as well. So we can do those assignments and then check what we got. So if we type in M, we see that that is seen as 1. If we type in P, we also get 1 in this situation. Maybe we want to assign 25 to N. We can do that as well. And type in N and see that we get 25 back. Or perhaps we want to use some words in our names. So we can have a really long number, for example, with words and periods. Or we could have a really small number, which also uses capital letters and small letters. If we run those, we can see that we've created assignments. They appear up here in our workspace. But we can also type it in to see what we got. So for example, a really long number will give us 1, 2, 3, 4, 5, 6, 7, 8, 9. Or a really small number will give us back what we put in for that as well. Words can also be used in a variety of different ways with R. So for example, if we want to assign 10 to stupid and 5 to face, we can do that. And then we can also use them with various mathematical functions. So maybe we want to divide stupid by face or subtract stupid from face. We can do both of those and see what we get in that particular case. We can also assign various words to different letters and names. So say we want to call H hello. You do want to make sure to use the double quotation marks around hello, but we can assign that and see that when we type in H afterwards, it's going to give us back what we told it what it was, hello. We can also use our concatenate function too and add hello and world together for HW. And that is going to give us hello world here. It's important to remember that R is case sensitive though, which means stupid with a small s does not equal stupid with a capital S. So here if we type in stupid with a small s, we're going to get back what we called it with 10. But if we type in stupid with a capital S, it's not going to be able to find it because we haven't actually assigned it to anything. So we get this error down here that object stupid was not found in R. So we just saw how to use vectors and assign values. Now let's see how to actually store vectors and calculate values with them. So in addition to assigning a single number to a letter or a name, we can also assign vectors and even more than that. So for example, say we want a vector of 1, 2, 3, 4, 5 again. Using our arrow and our colon, we can assign 1 through 5 to x in this case. So let's assign that, and then we can see down here that x is now 1, 2, 3, 4, 5. Now let's just go and assign the number 10 to y in this situation. So we say assign 10 to y. We have that done. And let's see what happens when we actually try to do some math between x and y. So we want to add x and y. And what happens in this situation? Well, we see that we had 10 for y, but a vector for x of 1, 2, 3, and 4, and 5. So adding y to x is going to give us 11, 12, 13, 14, and 15. So it's added 10 to every different value that was inside of x. We can also look at our values of x and y again, see what we had here. And we can also assign different things using x and y. So say we want to create a new vector that is equal to everything that we had in x plus y. We can do x plus y and assign that to z. And we'll see that, again, we get 11, 12, 13, 14, and 15. So overall, vectors can be very useful in certain math problems, as you'll see. So let's take an example. Say Sue and Bill received the following grades in an English class on different exams and papers. So we have Sue's grades here, 98, 84, 72, 76, and 95. We also have Bill's grades, 65, 86, 77, 67, and 85. And we can also list our different tests. So we had our first 2 papers and then our 3 different exams. So say we want to do some mathematical calculations between these. We can start by assigning each of their grades to a vector. So let's start out creating grades.Sue, which is going to be all of Sue's grades. We can use the concatenate function and our arrow to assign them here. The same thing with Bill's grades. And we also want to create a vector of the different names of our tests. So we can call that tests and list our different names here. And remember to use quotation marks because we're using words in this case. So let's do all of that. We've assigned everything, and we can also look at it as well. So we have our grades.Sue, our grades.Bill, and finally our different tests. These are now all vectors that we can use to calculate different mathematical functions. And we can also look at the structure of our vector. So for example, maybe we want to know the different entries in our vector type. We can use the function str to give us that. And if we do that with grades.Sue, we'll see that we have a numerical vector with 5 different values and our different values here. Maybe, however, we just want to know the length of our vector. We can do that here and say length grades.Bill, and we'll see that it's length 5 in this case. We can also see what we have for tests with str, and here we see that it's a character vector with our different names of our different tests. So now that we have our vectors together and we've looked to see what we have inside of each of them, we can also analyze them in a variety of different ways. So say, for example, you want to know the mean grade for Sue and the mean grade for Bill. We can use the function mean to get those. If we run that, we see that Sue's mean grade was an 85, but Bill's mean grade was a 76. We can also find the maximum value or the minimum value using max and min over here. So let's see what Sue's highest grade was and what Bill's lowest grade was. Well, Sue's highest grade, her maximum grade was a 98, and Bill's lowest grade, his minimum grade, was a 65. In addition to finding averages and minimums and maximums, we can combine vectors as well. So say we want one long vector of Sue's grades and Bill's grades. Well, we can simply say concatenate grades.Sue and grades.Bill for all.grades. And as you see here, all of the grades are now in one long vector. In addition to combining things, we can also go along and identify parts of vectors. So say, for example, we just want one value from the different vectors we created. We can ask R to tell us that by using brackets and the number of the value that we want. So say we want the first value from the vector of grades.Sue. We do grades.Sue with a 1, and that's going to tell us it's 98. Or perhaps we want the third value from Bill's grades. Can do that. We can see that's a 77 as well. And maybe we just want to know certain subsets, not just one value, but a couple of different values. We can do that as well. So for example, we just want Sue's paper grades. We know that that's the first two values that we have in the vector grades.sue. So we're going to say concatenate those values 1 and 2 and call that paper grades.sue. If we do that, we see that we have a 98 and an 84 for Sue's paper grades. Let's look at Bill's paper grades and see what we get. Well, his paper grades were a 65 and an 86. We could do the same thing if we want just exam grades. So for example, if we want the exam grades, we know that there are values 3, 4, and 5. So we say concatenate grades.bill for values 3 through 5. And that will give us our exam grades for Bill, a 77, a 67, and an 85. And we can do the same thing for Sue's exams grades as well. So this tutorial has covered a lot of stuff about R. You may want to take some time now to run through some of these commands and see if you can get the same results as we did together. As a final thing for this tutorial though, I want to mention some other helpful functions. So R is great because if you need help, R is there for you. And there are several different ways to ask R for help. You can use a question mark or just help to ask R to tell you about different functions or different things that we can do. So for example, if we type in paste, R is going to tell us about how to paste things together using that function, and the help files will appear right here in this additional window, and we can see what we can do with the command base, in this case of R, and all the different things that are associated with it. We can also type in help with paste in parentheses, and that'll lead us to the same thing as well. In addition to the help function, there are different functions that can help us navigate the workspace. So for example, ls in parentheses will give us a list of the objects that we've created so far today. We can also remove different objects and see what happens here. So say we want to get rid of x, which we have here, we can type in rmx. That's going to remove x, and if we look at this list again, we'll see that x is no longer present here. So these are just a few of the basic commands in R that are going to be helpful as you're using R to work on your different homeworks and your different lab projects as well.